graph. So remember hydrograph is a very important chapter. So what is delayed interflow? So water which this is your ground surface, and assume that there is a river flowing down here. Water which enters into the ground, which will flow within the ground surface, and after some time it will come out of the ground. Then finally it will flow on the ground, and finally it will reach the water body. Such kind of flow is called as a subsurface flow or interflow. If such kind of flow is taking more time, then in that case we call it as a delayed interflow. Am I clear, Mr. Avinash? Okay, now we shall go for hydrograph. Hydrograph, see, one by one we shall go. Basically, first point, flood hydrograph. Storm hydrograph. Or you can call it as third one. So hydrograph. All are same. So all are same itself. So this hydrograph is basically a plot between river discharge versus a time. So river discharge Q versus time. River discharge generally it will be in terms of meter cube per second. Time will be in terms of hours. Now, basically, so let me show you hydrograph in the next page. See here. Second point, hydrograph I will show you. So this is a hydrograph. River discharge on y-axis, x-axis, time in terms of hours. So 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on. Now, your hydrograph is a plot between river discharge versus time. Okay. Okay, this is your hydrograph. So you will get a box width here. So here we mentioned duration is mentioned generally here. Okay, this is your peak discharge, QP. QP is peak discharge. Okay, it will be in meter cube per second. the page. Give me a moment. I am refreshing the page. Okay. Now see, this is a time interval delta t. D is representing duration. It will be in terms of hours generally. Delta t is time interval between ordinates. Now here, this is nothing but base flow. Above part is nothing but direct runoff. So this is your hydrograph. Now from this hydrograph, suppose if I remove base flow. So if I remove base flow, I'll get direct runoff hydrograph. So third point what you have to remember is that direct runoff hydrograph. So in short, we call it as DRH. So how to obtain DRH? DRH is equal to flood hydrograph minus base flow. So DRH is equal to flood hydrograph minus base flow. So from this hydrograph, let me copy this hydrograph here. So from this hydrograph, if I remove base flow, so I am removing base flow in the right side diagram. See, so I am removing the base flow. So if I remove the base flow, so I will get a direct runoff hydrograph. So I removed the base flow. So I'll shift the x-axis and y-axis. Okay. So this is a shifted x-axis. So this will be delta t. I'll shift even the y-axis. So Q in terms of meter cube per second. X-axis is time in terms of hours. Now from here to here, this will be your time base. So this we shall call it as QP dash, because QP dash is equal to QP minus base flow. Peak of a DRH is equal to peak of a fluid hydrograph minus a base flow. So this is your resultant DRH, direct runoff hydrograph. Now we have solved some problems. We have written some many points. So this I'll take one more ordinate. This has one more ordinate. So this we can call it as O1 dash, O2 dash. Similarly, further things. Now, next points. So this is your DRH. Now, next point is that fourth point. So if you want a DRH, so we know that so DRH is nothing but flood hydrograph minus base flow. Flood hydrograph minus base flow will give you DRH. Now fourth point. So sentences you have to remember, if I want to find out peak of DRH, then nothing but peak of flood hydrograph minus base flow will give me peak of DRH. Similarly, suppose if I want to find out any ordinate of DRH, any ordinate other than peak, so it will be ordinate of flood hydrograph minus base flow. Sixth point. So if I find area of DRH, so I'll get runoff volume. Seventh point, area of DRH is equal to catchment area into runoff depth. Eighth point, we have proved that area of DRH is equal to delta T into summation of O dash. So by dividing the complete area into small areas, we have proved this one. Ninth point, delta T into summation of O dash is equal to catchment area into runoff depth. So all these things we have seen. I hope so you remember one by one. So 10th one, phi index formula is P minus R divided by T for uniform rainfalls. So what you can write is R is equal to P minus phi into T. So from exam point of view, for you, this is important. This is important. These are important. So this is about your DRH, direct runoff hydrograph. Now next thing, unit hydrograph. Now in a unit hydrograph, you have to remember. So in short, we represent it as UH. For any unit hydrograph, runoff value will be equal to 1 centimeter. So for any unit hydrograph. That is, suppose if I take 1 hour unit hydrograph, 2 hour unit hydrograph, 3 hour unit hydrograph, continuously if I take till d hour unit hydrograph, so for any unit hydrograph, runoff value will be always 1 centimeter. Second thing, something we have defined, effective rainfall intensity. In short, we call it as ERI. ERI is equal to 1 by D centimeter per hour. ERI is equal to 1 by D centimeter per hour. This is what we have proved. Now in DRH, now we can take different cases. Suppose if it is a triangular unit hydrograph, triangular DRH, so in this case, area of DRH will be equal to catchment area into runoff depth. So area you can use half into base time into QP. That is equal to catchment area into runoff depth. So conversions you have to make accordingly, okay, of units. So you get case 2 also. So case 2 will be this same diagram. So that is nothing but delta T is the same. So in this case, area of DRH will be equal to catchment area into runoff depth. So area of DRH, if delta T is the same, you can take this formula. Delta T same means this thing you have to take delta T into summation of O dash. Third one, you can get trapezoidal. So suppose if you get a trapezoidal shape, so in this case, area of DRH is equal to catchment area into runoff depth. Area of DRH you can take A plus B divided by 2 into your QP, that is equal to catchment area into runoff depth. So these are the three cases: triangle, delta T same, and trapezoidal. So one more case you will get, fourth one, that is delta T different. Suppose if you get the delta T different, then what you have to do is area of DRH is equal to catchment area into runoff value. So here in this case, area 1, area 2, area 3 separately you have to find out. So area 1 plus area 2 plus area 3 will be equal to catchment area into runoff depth. Separately you have to do. So these are 4 cases which are possible in a direct runoff hydrograph. First one, you may get a triangle. So you have to use a triangle formula. Second one, delta T constant. You have to use delta T into summation of O dash. So third one, trapezoidal. You have to use trapezoidal formula. Fourth one, delta T different. You have to find out areas separately. So these are the cases with respect to your DRH. Now, in unit hydrograph, first thing you have to remember is that whichever unit hydrograph you take, so runoff value will be equal to 1 centimeter. Whatever may be the duration of unit hydrograph, your runoff value will be equal to 1 centimeter. So in case of your unit hydrograph, effective rainfall intensity ERI value will always be 1 by D centimeter per hour. Next point, basically you have to remember this unit hydrograph you have to obtain is DRH value you have to divide by R centimeter into 1 centimeter. So nothing but ordinates of unit hydrograph is equal to ordinates of DRH divided by R centimeter into 1 centimeter. Suppose if I am speaking about peak of unit hydrograph, you can write peak of DRH divided by R centimeter into 1 centimeter. So finally, end result what you have to remember is that DRH basically is equal to flood hydrograph minus base flow. This is the first logical point you have to remember. Or the same thing what you can write is flood hydrograph is equal to DRH plus base flow. Next point what you have to remember is that unit hydrograph is equal to the above 12th point only DRH by R centimeter into 1 centimeter, or you can remember DRH is equal to UH into R centimeter divided by 1 centimeter. So these logical points you have to remember. These are very important, which will help you to solve problems. 14th point. Steps to derive unit hydrograph. So first one, consider a flood hydrograph. Second point, remove base flow from above flood hydrograph. If you remove base flow from above flood hydrograph, it will result in which graph? DRH. So you will get DRH. Third point. Now you know DRH. You find area of DRH, which will give you runoff volume. So if you find area of DRH, you'll get runoff volume. Fourth step, so this runoff volume, when divided by catchment area, you will get runoff depth. Runoff depth R is equal to runoff volume divided by catchment area. So last step, you know DRH from the second step, you know runoff value from the fourth step. So unit hydrograph is equal to DRH from your second step divided by R value from your fourth step into 1 centimeter. You will get a unit hydrograph. So these are the steps to derive unit hydrograph. So these are the steps now to derive unit hydrograph. Next thing. 15th point. Unit hydrographs of different duration. Now there are two methods. First one is method of supervision. Basic definition is given is D our unit hydrograph. We are supposed to derive MD our unit hydrograph. So first method is method of superposition. So this you use when M is an integer. So M 2, 3, 4 and so on. When M is an integer, you can go for method of superposition. Second one is S curve method. So this you use generally when M is a fraction, but also you can use when M is an integer. So when M is a fraction also you can use, when M is an integer also you can use this S curve method. So I'll refresh the page. Generally I'll be refreshing after every Okay, I hope so now it is fine. So let us go for method of superposition. Today for you one important announcement from 11 a.m. to 1:30 p.m. you will be having RCC class. Today only. Okay, after my session, there will be RCC class for you. So method of superposition. So method of superposition. So given is a d-hour unit hydrograph. So let me consider a d-hour unit hydrograph here. What is this? Okay, assume that this is the d-hour unit hydrograph given for you with a time base of TB. So from this, you are supposed to derive MD our unit hydrograph. Okay. So when you go for method of superposition, when it is a integer. Now please see here, remember one thing. So whatever the value of m may be. So let us consider value of m as a consider m is equal to 3 now. So I have considered that m is equal to 3. So given is a d-hour unit hydrograph. D-hour unit hydrograph means R value will be equal to 1 centimeter. Now first logical thing what you have to remember is, suppose if my m value is 3, means the same graph totally 3 times you have to draw. So totally 3 times you have to draw. Each should be lagging by d hours. That is the important thing. So first one always should start from 0. Right click, copy this graph and paste. So first time I have drawn 0 to TB. Second time when you draw, so for this R value will be equal to 1 centimeter. So second time when you draw, it should lag by D hours. So it should start from D. So this will be lag. D hour. Now, if I start from here, it has to end by TB plus D. Third time, for this also runoff will be 1 centimeter. Third time, so it has to, again you have to provide a lag of D hours. So it will start from 2D. So if it starts from 2D, it will end by TB plus 2D. So for this also R is equal to 1 centimeter. So in this method of superposition, the only mistake student will do is that lag. So lag should be always D hours. So each unit hydrograph should lag by D hours. Now, next thing, what you have to do is that you have to add all these curves. So if you add the corresponding ordinates, so it will result in a DRX. You will get DRX due to R is equal to 3 centimeter. that is nothing but YAMO value. So add all the curves. So finally you will get one huge curve. It will start from 0 and it will end by this TB plus 2D. So this curve will be your DRH. So for this curve, runoff value will be equal to 3 centimeter, that will be equal to YAMO centimeter. Now what you have to do is that, so now you know DRH divided by that R value into 1 centimeter. If you do, you will get finally unit hydrograph. So that unit hydrograph, you can show it somewhere like this. So this will be your EMD, our unit hydrograph. So these are the steps. So what you have to remember while drawing the table or thing is that you have to provide lag properly. Lag should be always D hours. And next thing is that, so providing lag is important. Then the resulting DRH will be having a R value of YAMO centimeter. Those 2 points you have to remember. Now next thing, yes curve method. So equilibrium discharge equation you have to remember 2.778 A by D. That is the first point you have to remember. Second point you have to remember is that while deriving S curve, lag provided should be D hours. Third point what you have to remember. So in this equation, QE will be in a meter cube per second. Area should be in kilometer square. Duration should be in terms of hours. Third point, while deriving S curve, you should remember that lag provided should be D hours. Next thing, SB curve. So you write SA and SB curve. So SA curve should start from 0 always. SA curve starts from 0. Fourth point, SB curve lags by T hours from SA curve. Fifth point. So your T hour unit hydrograph will be equal to SA minus SB divided by T by D centimeter into 1 centimeter. So these are the points which you have to remember with respect to S curve. Am I clear? Okay. So this I'll be uploading the PDF after the class. Don't worry. Now these are the points which you have to remember for S curve method. So this is 16th point. This is 17th point. 18th point, what you have to remember is that so 18th point. So suppose whenever there are two successive rainfalls, suppose assume that on a particular day rainfall started at 9 a.m. continuously it is there till 9 p.m. and there are totally three different rainfalls: 9 a.m. to 1 p.m., 1 p.m. to 5 p.m., 5 p.m. to 9 p.m. So three different intensities. So T1 is equal to 4 hours, T2 is equal to 4 hours, T3 is equal to 4 hours. So whenever you are having two or more than two rainfalls occurring in succession one after the other with different intensities, I1, I2, I3. So with respect to this, you will get P1, P2, P3. So with respect to this, you will get three runoff values R1, R2, and R3. So whenever there are two or more than two rainfalls of same duration occurring in succession, you have to go for convolution method. So when there are two or more than two rainfalls of same duration occurring in succession, use convolution method. Whenever there are such kind of consecutive rainfalls of same duration, you have to go for convolution method. 19th point, theoretical point. So basic assumptions. In unit hydrograph. So remember 2 points here. So first one is linear response. Second one is time invariance. Twentieth point, instantaneous unit hydrograph. It is a unit hydrograph of shortest possible duration. Next point. So ordinates of instantaneous unit hydrograph represent slope of S curve with an effective rainfall intensity of 1 centimeter per hour. Last theoretical point what you have to remember is that so your unit hydrograph theory is applicable for catchment areas less than 5,000 kilometers square and greater than 200 hectare. So these points you remember and some graphs. So some more theoretical points I'll write. 22. As duration increases, time base increases, but peak discharge QP decreases and peak is shifted to right side. I hope so you remember this point. So same thing, opposite also you can write completely. Twenty-third point, as duration decreases, time base decreases, but peak discharge increases and peak is shifted to left side. So these are the points which you have to remember with respect to this chapter, hydrograph completely. Then chapter 8, maximum flood estimation. So somebody raised hand, any doubts? Okay. So maximum flood estimation, first point you have to remember rational formula. So rational formula QP is equal to KPC into A divided by 36. QP is peak discharge in meter cube per second. K is runoff coefficient. PC, design rainfall intensity. It should be in terms of centimeter per hour. Capital A, catchment area in hectare. So this is the only formula which is important from this topic. Next, if you possible, you remember this flood frequency analysis. So formulas I have given in detail. XT, extreme flood or maximum possible flood is equal to X bar plus KT into sigma. X bar is the mean flood. XT is the extreme flood. X bar mean flood. KT frequency factor. Sigma standard deviation. So there is an equation for KT. Kt is equal to Yt minus Yn divided by Sn. Yt is equal to minus ln of 1 minus P. P is equal to 1 by T. So this formula, if possible, remember, but not required that much. According to me, this chapter is not so important. So next will be chapter 9, flood routing. So it is 9:10. Shall we have breakfast? Synthetic unit hydrograph is not so important. So we shall take a break of 20 minutes. So we shall start by 9:30 a.m. Okay. I am hungry, bhaiya. I have to eat something. Okay. At least I'll have a cup of coffee at least. So take a break. So after that we shall complete. Okay. So remember this thing. We will be having a RCC class today from 11 a.m. to 1:30 p.m. So I'll start from 9:30. So we shall take a small break. So welcome back. So we shall start with flood routing. So in flood routing, so methods of flood routing. First method, hydrologic routing. So it uses equations of continuity. Hydraulic routing. It employs, so these are important points. Equations of continuity and equations of motion of unsteady flow. Okay, so this is what you have to remember. Next, there is one equation. Muskingum method. First point, it is a hydrologic channel routing method. Second, Q2 is equal to C0 into I2 plus C1 into I1 plus C2 into Q1. This equation you have to remember. Third thing, sum of Muskingum coefficients is equal to 1. Fourth point, in case of linear storage or linear reservoir, storage is a function of outflow only. Fourth point, last important point, in case of uncontrolled flows, peak of outflow flood hydrograph peak of outflow flood hydrograph lies at the intersection of inflow and outflow flood hydrograph. So next, there is a term called attenuation and lag. So in attenuation and lag, so if you draw flood hydrographs, inflow and outflow flood hydrograph, so assume this is inflow flood hydrograph. Hello? Hello? Someone has raised their hand. Hello? No doubts? Okay. This is inflow flood hydrograph. This is peak of inflow flood hydrograph, QP1 I will call. So if you plot the outflow flood hydrograph, this is your outflow flood hydrograph. Let this be the peak of outflow flood hydrograph. So it is occurring at time T2. Peak of inflow flood hydrograph is occurring at time T1. So the difference between these two, in peak values is nothing but called as attenuation. So this time difference T2 minus T1, this is called as lag. So these are the points which you have to remember from flood routing. So last topic which is important from your exam point of view, chapter 10, well hydraulics. So first thing you should remember Darcy's law. So in Darcy's law, what you have to remember? Equations. So hydraulic gradient I is equal to loss of head divided by seepage length. Second one, discharge velocity is proportional to hydraulic gradient. Third one, V is equal to K into I. Fourth one, discharge is equal to area into velocity. Fifth point, discharge is equal to, you can write KIA. Sixth one, seepage velocity Vs is equal to V divided by N, porosity. So porosity will be less than 1, greater than 0. So seventh point, Vs will be always greater than V. Eighth point, what you have to remember is Vs is equal to distance divided by time. So these are the points that you have to remember from Darcy's law. Then next thing, unconfined aquifer formulae. Q is equal to pi into K H2 square minus H1 square divided by ln of R2 by R1. Q is equal to pi into K capital H square minus HW square divided by ln of R by RW. Then coefficient of transmissibility is equal to K into H. These are unconfined aquifer formulae which you have to remember. Then confined aquifer formulae. Q is equal to 2 pi T into S1 minus S2 divided by ln of R2 by R1. Q is equal to 2 pi T SW divided by ln of capital R divided by RW. T is equal to K into B. So these are confined aquifer formulae which are important from exam point of view. Last one which is important for you is specific yield plus specific retention is equal to porosity. Specific yield plus specific retention is equal to porosity. specific yield is equal to VWY divided by area into Z. Area into Z. So SY is specific yield. SR specific retention. N is porosity. Then A is area of aquifer. Z is depth. VWI represents volume of water pumped out, or you can say volume of water drained out, or you can say volume of water lost, or you can say change in groundwater storage. Okay, so these are the important formulae which you require from this topic, that is well hydraulics. So these are more than sufficient. So I hope so these are the things which you remember now. So this is about your required things which are important from exam point of view. Try to remember at least these things. Now, if anyone is having any doubts in any conceptual thing, you can ask. Okay, if anyone is having any doubts, you can raise your hand, we shall discuss. So I hope so these are more than sufficient. Now, from your exam point of view, chapters important will be well hydraulics. I hope so you have prepared well for that well hydraulics. Then important will be your infiltration chapter. The next important chapter will be hydrograph. Sorry. So hydrograph, infiltration, and well hydraulics are important chapters. So these are important chapters which you have to remember. I hope so you have prepared well for the examination. So all the best for your examination. So if there are any doubts, you can raise your hands. So all the best. I hope so you will do well in the examination. I hope you have prepared well. So if there are any doubts, you can ask me. So remember one thing. I hope so all of you will be writing in the examination this year. Now, first thing, please remember. So please don't be in a hurry in the examination. Some points I will tell you. Please try to follow these things. First thing, never be in a hurry in the examination. So when you will be in a hurry now, what happens? Automatically you will make minor mistake. So because of minor mistake only, every time many of my students will say, sir, I lost 10 marks, I lost 8 marks. Minor mistake means in units and all. So the question which will be easy, sometimes those questions also will make mistake. Why? Because easy question, what you will do is you will be overconfident. So never make that thing. Don't pressurize yourself. Be cool, as like our captain Dhoni. So have a cool mind, have a relaxed mind. So I hope so you must have studied some subjects and all. I hope so you must have covered all the things. That will be better. So for the remaining days, you try to revise the things. Don't study new things. New things won't help you out now. It will be difficult. So try to revise as many as times as possible the formula and all. Okay. So yes,
Sir, you said you'll solve some questions.
yes.
You'll solve now, sir.
You want me to solve questions?
Yes, sir. You said you'll solve some important questions.
Important means the same thing. If any doubt is there on any method, that problems I will solve. You have any doubt in any problems, any method?
Sir, in S-curve method,
Okay,
like,
yes, curve problem I will solve now. Is it
okay,
fine?
sir. Okay, sir.
Okay. Give me a time so that I'll find a question.
Okay, sir.
So I'll solve a problem related to S curve. So give me a little bit of time so that I will find the question. Okay. So let me solve a problem related to S curve. So this is a problem related to S curve method here. Now first things here, what is given in this question? So the ordinates of 3-hour unit hydrograph at 1 hour time intervals. 3-hour unit hydrograph is given. Delta T time interval is given as 1 hour. Starting from time T is equal to 0. Values are given 0, 5 by 3, 13 by 3, 18 by 3, 16 by 3, 9 by 3, 4 by 3, 1 by 3 and 0. Derive 1 hour unit hydrograph. So first thing, you have to prepare a table. Okay. So in the S curve, what you are supposed to remember, I told you. So first thing, first column will be time in terms of hours. So as in the problem, he has mentioned starting from time interval t is equal to 0. So 0, 1 to time interval is given 1 hour. So 0, 1, 2, 3, like that you'll get 3, 4, 5, 6, 7, 8. Next column should be you are given a 3-hour unit hydrograph. So this is your given 3-hour unit hydrograph. Values are given 0, 5 by 3, 13 by 3, 5 by 3, 13 by 3, 18 by 3, 16 by 3, 9 by 3, 4 by 3, 1 by 3, 0. So first thing is that you have to derive S curve. I gave you a point here. While deriving S curve, you have to provide a lag of D hours. So in this example, D is equal to 3 hours. So while deriving S curve, you have to provide a lag of D hours. So first, S curve addition column, then S curve. S curve addition. So this is S curve. Now for S curve addition, you have to provide a lag. So as it is a 3-hour unit hydrograph given, you have to provide a lag of 3 hours. Lag D hours. So lag 3 hours means you have to start from here. You have to start from 3. So you don't get any value here. Here you don't get any value. Here you don't get any value. So 3 spaces you are leaving now. So at a time what you have to do is these 3 values at a time you have to start dropping. So drop this value here. So at a time you have to drop 3 values. So 0, 5 by 3, 13 by 3. Now 3 values again you have to drop to the left hand side at a time. These 3 values you have to drop to the left hand side. So as you are left 3 spaces, you have to drop 3 values at a time. If you are leaving 2 spaces, you have to drop 2 values at a time. So 0, 5 by 3, 13 by 3. Now add 18 by 3 plus 0 is 18 by 3, 16 by 3 plus 5 by 3, 21 by 3, 9 by 3 plus 13 by 3, 22 by 3. Now these 3 values at a time you have to drop to the left hand side now. (18 by 3, 21 by 3, 22 by 3. 4 plus 18, 22 by 3, 1 by 3 plus 21 by 3, 22 by 3, 0 plus 22 by 3, 22 by 3. S curve over. Now you have derived S curve. Okay, fine. You have provided a lag of D hours. So this is a mistake student will do. So provide lag properly. If you are leaving 2 spaces, drop 2 values at a time. If you are leaving 3 spaces, drop 3 values at a time. If you are leaving 1 space, drop 1 value at a time. Okay. Next thing. SA curve should start from 0. So already this is the S curve which is starting from 0. So SA curve should start from here. So this is S curve addition here. Okay. SA curve should start from 0. As this itself is the S curve which is starting from 0, I will call this as SA curve. Your next column should be SB curve. SB curve. Now SB curve. So SB curve lag by T hours from SA curve. So what is T in this problem? You are deriving 1 hour unit hydrograph. So from 3 hour unit hydrograph, you are deriving 1 hour unit hydrograph. So in general, nothing but we write D hour unit hydrograph, derive MD hour unit hydrograph, or D hour unit hydrograph, you have to derive T hour unit hydrograph. So M into D completely we call it as T, that is nothing but 1 hour. So your SB curve should lag by 1 hour. So SB curve lags by T hours from SA curve. So SB curve should lag by T hours. So here you have to provide lag T hours. So that is nothing but lag 1 hour. So your SB curve should start from 1. So you cannot start from here, you have to start from 1. So write the values here: 0, 5 by 3, 13 by 3, 18 by 3, 21 by 3, 22 by 3, 22 by 3, 22 by 3. So next column should be SA minus SB. Zero, 5 by 3, 8 by 3, subtract, that's all. So 5 by 3, then 3 by 3, 1 by 3, 0, 0, 0. Now finally, T hour unit hydrograph, that is nothing but 1 hour unit hydrograph is equal to SA minus SB divided by T by D. T by D is nothing but 1 by 3 now into 1 centimeter. So all these values you have to divide by 1 by 3. So divide by 1 by 3, you will get 0, 5, 8, 5, 3, 1, 0. So peak value, if you want, you can take it as 3. This is your peak value 8. So main thing is that while deriving S curve, you have to provide a lag of D hours. While writing SB curve, you have to provide a lag of T hours. Am I clear with this S curve here? So this is your S curve problem. So anything else? Any other doubt? You can raise your hand. No doubts? Okay. So these things I will be uploading it. So all the best for your examination. Okay, which slide? So here I1 and I2 are inflows at a time of T1 and T2. Q1 and Q2 are outflows at a time T1 and T2. C0, C1 and C2 are Muskingum coefficients. Okay. Now please see here. So in the examination, please don't be in a hurry. Always try to be calm. So yes curve question I have solved just now, na? So if you are going for convolution method, so I'll show you a table. So time in terms of hours. I will take the same examples here. So totally T1, T2, T3. Each rainfall is with respect to 4 hours occurring in succession. So what I have to do is, so assume that I am having a 4-hour unit hydrograph at 0, 4, 8, 12, 16, 20, 24 and so on. So these are the values, these are the ordinates at 4-hour interval. So I'm having some values A, B, C, D, E, F, G like that. So totally how many rainfalls are there? 3 rainfalls are there. So 3 rainfalls occurring in succession. So totally 3 DRH columns you will get. First DRH, second DRH, third DRH. So first DRH. So it will be equal to unit hydrograph into R1 divided by 1 centimeter. So first DRH should start from 0. So here it will be A into R1. Here it will be A into R1, B into R1, C into R1. Okay. So there is a 4-hour unit hydrograph given at 4-hour intervals. So there are 3 rainfalls, each of 4-hour duration. 4 hours, 4 hours, 4 hours. So 3 runoffs, R1, R2 and R3. R1 is starting from a starting time 0 to 4, 4 to 8, 8 to 12, total 12-hour rainfall. So R1 is starting from 0. So that is nothing but this thing. So it should start from 0, A into R1, B into R1, C into R1, D into R1, E into R1, F into R1, G into R1. Similarly, second DRH will get. Second DRH is equal to unit hydrograph into R2 by 1. Now second DRH is due to R2. R2 is starting from which point C? R2 is starting from 4. R2 lags by 4 hours. So you have to provide lag 4 hours. So here you are supposed to start. Second one. So you will not get any value here. So now you have to start writing. You can see the arrow marks. So what you have to start here is that here it will be A into R2, B into R2, C into R2, D into R2, E into R2, F into R2. Now third DRH. Due to third rainfall, unit hydrograph into R3 divided by 1. So your third rainfall is starting from 5, that is nothing but 8. So you have to start from 8 here. So total lag will be 8 hours from first one. So you will not get any value here, you will not get any value here. So you have to start from here. So from here it will be A into R2, B into R2, C into, sorry, R3, na this is R3, D into R3, E into R3. Third one with respect to R3. Now finally, you will get one more column here. So total DRH 1 plus 2 plus 3. First 1 plus 2 plus 3. This will be your total DRH. So for this, if you add your base flow, so flood hydrograph will be equal to DRH plus base flow. You will get a flood hydrograph value. This is how you are supposed to solve the problem by convolution method. So anything else? So I hope so there are no doubts. So for you now, from 11 a.m. to 1:30 p.m. you'll be having RCC revision class. So stay calm in the examination. Don't be in a hurry. Have a relaxed mind. So whatever you have learned till today, so try to revise as much as possible. And some people will be taking it as some people will take it in a negative way. What is that? I hope so. You must have attended test series. So in test series, is repeated in the examination. Am I clear? So just a minute, I will refresh the page. I'll refresh the page. So anything there you can ask, or else we shall end the session. All the best for your examination. Don't do minor mistake. So hope for the best. I hope so everyone will get a good rank. So this year most of you learned from online only. Okay. All the best for your examination. Study well. Shall I end the session? So I hope so there are no doubts. So all the best for your examination. So I'll end the session here. So somebody raise hand. So if you want to ask something, you can ask. Yes? Nobody? Yes. Hello?
Good morning, sir.
Good morning, yeah.
Sir, how many test series should be written, sir, to get confidence?
It depends upon you. Try to write all the test series so that you will find variety of
No,
questions.
sir, we don't have enough time and we have to prepare lot
Now
of
you,
things. Then how
now
many
you,
test series should be written?
now that you don't have time to write test series, you try to first revise all the things which are there.
Yes,
Test
sir.
series generally you should have written in the month of December, January only earlier part.
Yes, sir.
If you want, you can. If you are prepared enough, prepare well still, and one or two tests you can attend.
Yes, sir.
One or two full length tests
Sir,
you attend.
full length test. Sir,
Full
if I
length test.
attend subject wise test?
Subject wise now it is not. It will take a lot of time, na.
Yes, sir.
Have you prepared all the subjects?
No, sir.
How many subjects you have prepared?
Sir, I left steel, engineering mechanics,
Uh,
and half portion fluid mechanics.
remaining?
Remaining I am preparing, sir. Means
G-
non non-structural. I have completed nearly 80%.
Okay, then try to revise those things. Okay, write
Okay,
one
sir.
or two tests. For
Yes,
example, which are important subjects: GT, environmental, RCC.
yes, sir. Yes, sir.
Those you can attempt the full length test. Sorry, subject wise test. Okay,
Yes, sir.
and get confidence and try to write the exam. Okay,
Okay, sir. Sir, thank you, sir.
all the best, yeah. Thank you.
Thank you, sir. Thank you, sir.
So anyone else wants to speak, wants to ask anything? So thanks a lot. All the best for your examination. So there are no doubts. Let me end the session.